Example 6, here we go. Express each using summation notation, okay? So now I'm giving you guys a bunch of different numbers here, and then your job is to go back and use your summation notation and then put it together. No, so now I'm sorry. Whenever you guys see these, my recommendation is start writing like first term, second term, third term. If that's the third term, as you can see, this is number 8, so that's probably the 8th term, okay? Your summation notation, as you know already, the bottom of the summation notation is where what number we would like to start. I would say 99% of the time, I want to start with number 1. If we're starting at number 1, based on this sequence, we end at 8. So the top is the number that we would stop. Now we just have to come up with a formula that every time we put in k, it will give us the 1 to the 3rd or 2 to the 3rd or 3 to the 3rd. In this case, it looks pretty easy, right? The first term when k is 1, all of a sudden it's just 1 to the 3rd. Second term is 2 to the 3rd, and third term is 3 to the 3rd. So this formula then, every time you plug in k, it's just k to the 3rd, and that's it. Not all the time that is that easy, right? Now let's go to number 2. I'm sorry, not number 2, letter B. Letter B again, I'm going to use, I'm going to let this be first, and let this be second, let this be third. And looks like we have n here as our last term. Not all the time that we would be able to have a number or a constant on the top. And again, as I told you guys already, I normally start with k equals to 1. When k equals to 1, so if this is k, right, when k is 1, it looks like it's 1 over e. When k is 2, well, it's 2 over e squared. When k equals 3, 3 divided by e to the 3. So if you look at the pattern, which is what math is, right? Math is a pattern of science. Would you agree that I can just have k over and then e? But that's not really fully done yet because this e has a power of k as well. So that would be okay to have. Now, where do we stop? Which is we need to write something on the top of the summation notation. We stop at n. So this is the final answer. One more on example 6. So on example 6, I will have first term, second term, third term, and so on and so on. So we can start with, I'm going to start here, k equals 1. For this one, guys, I'm going to do 2 different answers for the summation notation, okay? Some of you like to start at 0, and that's okay. All right, so if we start at 0, so let's say that this is my first term when k equals to 0 here. Let's work on this one first, okay? So when k equals to 0 on the right side, I have a, okay? Now when k is 1, I have a times r. Well, when k is 2, which is my third term, I have a r squared, and then dot, 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 dot. So can you guys see that every time, we plug in k, the power right here is the same as the k if we are starting at k equals to 0. Okay, so with that said, I can go in and say, okay, a is always constant, so I'm gonna keep that. But the variable r changes its power every time I plug in k. So you guys can see that I can just use that as my answer. Now where do we stop? We stop right here. So n minus 1 is where we're stopping. Now what if we start at k equals 1 on the right side? Then you have to go and see, okay, well, if I start at k equals 1, which if I'm using this, I'm going to add 1 here, right? That means I want to n also add 1 there. Now, if I add 1 to the starting position, which is on the bottom of the summation notation, and add 1 to the top, which is the n number of your summation, I would now have an n. Okay, but that doesn't mean you can just go in and just add k, like add 1 to this formula. That's not going to work. So make sure we look at each number, okay, carefully. So what would happen if we plug in 1 to start with? So let's go and plug it in. Okay, ready? When k equals 1, I have an a, okay? When k equals 2, this is my second term, I have AR, so R to the first power. When k equals 3, that's my third term. This is 1 less. So your formula, students, for this one, it's A times R to the k minus 1. Okay, so that's what's happening. All right, so those are the two equations or two summation notations that you can have, and either one should be fine. Now, on any equations, you can always come up with different formulas. I just have to verify the answer myself. Example 7, find the sum of each sequence. So now we are going to use the summation they give us to find the sum. The sum means an answer to an addition problem. Okay, so that one's super thick, isn't it? Let's see, probably. Okay, so for this one, when k equals 1, I have 8. Okay, so I need to add that. When k equals 2, I have 8. Because it doesn't change, it's a constant. When k equals 3, I have 8. So I'm going to keep adding 8, guys, all the way to my last k is what? 50. Well, guess what? I'm not going to sit here and add 8 like 50 times. So this allows you to go back to your formula. Can you guys go find your definition number 9? Okay, so definition number 9. There's a formula that looks like this. It starts out at 1, and then it ends at n, and there's a constant, C for constant, and we talked about this before. Then the formula says you can find the sum by just doing the constant times n, okay? And that's what we're going to do. We're not going to sit here and add 850 times on the test. What if I go, like to 9,000 times? You're not going to sit here and punch in 9,000 times. So we can use a formula. Your C is 8, and your N is 50. We can multiply that out. So if we sit here and add 8 all the way to 50 times, we should get an answer of 400. 400 is the sum. Okay. Let's go to B. Now, before we start B, it says here the summation k starts at 0, which is slightly different from A. K starts at 1. And it ends at 14, okay, when k is 14. So technically, we can go in and use the formula. If you go and look at definition number 8, I want you to go look and find definition number 8, okay. There is this formula right here. It says k has to start at 1, ends at n, and then it says A subscript k minus B subscript k is identical to the summation of k equals to 1 and to n times A subscript k, take away B subscript k. Okay, so this is already in your definition. Okay, so now you just have to know how to use it. But your definition here says k has to start at 1. Now your formula here, or your question here on 7b said k is currently starting at 0. Then we can't use the formula. That's not the same. So we just have to start with k equals 1 by using when k is 0. Okay, when k is 0. I'm going to plug it in. Ready? 0 squared minus 4, which equals to negative 4. So now I'm going to rewrite this, students. I'm going to have, okay, negative 4 is when k equals to 0. Then I'm just going to do the summation for the rest. I haven't done k equals 1 or k equals 2, k equals 3. I'm going to use the summation from k equals 1 all the way to 14. Okay, all the way to 14. And so I'm going to write this formula, this question back down. So students, all I'm really doing is breaking this up into when k equals to 0, get the constant here, and then recopy the problem for the remaining k values that we haven't used. All right, so now I can go and use this formula, right? Because now k is starting at 1. So with that said, I know exactly what to do when you have a quantity of summation according to your formula. If k starting at 1, we can break it up. K squared, and then we can do a minus, okay, summation k equals 1 to the 14th, 4. Okay. Now I know you can do this constant because we just got done with one constant here on 7a. So that means the constant formula said is your constant value 4 times the ending value. That will give you the sum, which is the answer of all those additions, okay? Now we have a negative 4, what's the when k equals to 0. Then I want you to go and look for the formula for this. I'm going to give you a couple of seconds to go look for it. Okay, so I hope you found it in the definition 9. And the formula said it's n times n plus 1 times 2n plus 1 all over 6. I'm copying down the formula for you. Well, what on earth is n? N is the n value. So now we can plug that in. Drop down negative 4 plus the n value is 14. 14 plus 1, and then 2 times 14 plus 1 all over 6. Now, I'm just going to multiply 4 times 14 out. That's going to be 56. And yes, you can use your calculator to do your basic math. When you work out the numerator here, that's going to be 90 over 6, and then subtract 56. And then when you do 90 divided by 6, that should give you 15, and then drop down 56. So the sum should give you 955. And that's all, y'all.